So what is the characteristic of the light that we can vary? Okay, Zainuzi.
The intensity of light.
Okay, intensity of light. Okay, light intensity. So apart from light intensity, what other light characteristic that we can vary? Light apa lagi? No, Hafizal.
Frequency.
Sorry, light frequency. Okay. Okay, so light intensity, light frequency. So apart from these three variables that we can vary, what else? Yes, anyone? Alex?
Emitter, work function.
Work function. Okay, so we can say is the metal, isn't it?
Yes.
So we just put work function. Because different metal has different work function. Okay. So, 1, 2, 3, 4. So, the last one. So, we have the voltage here. Alright, we can vary the metal for this one. And then we can vary the light frequency here. Normally, we use F here to denote the frequency of light. And that big intensity, I guess I better put intensity here. Okay, so as for light, we can vary these two things, the frequency and the intensity. We can change the metal, so that we can know what are the how work function affects the our measure affects photoelectric effect. Work function. Okay, so we know what are we can measure the voltage now. So 1. So next, lastly, what can we measure? Where we can use this one here, the variable voltage source, to vary the voltage in the circuit. So the last one is? Anyone? Anyone? Sorry, ni apa, Ang? Yeah?
Current.
Okay, so we can measure the current. So, the current, by using the ammeter. So these are all the basic variables in a photoelectric effect experiment. Next we will see how does if we vary the voltage, what will happen to the current. Next we can also vary the light intensity, a weak light and also a strong light. Change color. Color is right. Where is my? Okay, so the intensity we can change it. Either a weak light or an intense light, and then voltage source. We can make it delta V positive, and also we can also get delta V to be negative. So either positive or negative. So when delta V is positive, how is it that, so this one will be, if we are having delta V as positive, so this one is positive or negative terminal? So this one should be positive or negative terminal. If you would like our delta V to be positive, I mean the circuit to be positive, the voltage. So, no, Hafizan, look at. So this one should be positive ke negative?
Positive.
So this one should be
positive.
Positive, and this
Positive.
one negative.
Negative.
Yeah? Okay. So if this one is negative, then this one is negative. But because there's a difference here, whenever we have whenever the voltage across the circuit is positive or negative, we'll see later. Okay, so we can change the light frequency here. High F, F high, or the frequency lower. This one we can just change it, yeah? Easy, if we have the frequency, variable frequency equipment, yeah? Okay, so that's basically the variables that we can vary: the voltage, the intensity, the light frequency, and the metal, and we can see what's going to happen to the current. Yeah? Okay, so is there any question as for now for the experimental setup? Before we look into the findings of the experiment, and how are we going to explain what's in it? So is there any questions? No, it's pretty clear, isn't it? So there must be an emitter to emit the photoelectron, and then there must be a vacuum tube here, so that the motion or the movement of the electron won't be hindered by any particles in the tube itself. And then there must be a collector to collect the electrons.
Tanya boleh?
Yes.
What is the difference between the light intensity and the light frequency that we can vary for our, what is the difference between the intensity and the frequency?
The intensity and the frequency. So the intensity
the light, yes.
is whether it's bright, the brightness of the light. The brightness of the light is the intensity, whether it's low brightness or whether it's high, kecerahan dia, kecerahan tinggi ataupun kecerahan rendah. Tapi the frequency is different, because kalau kita tengok red light and blue light, it has different frequency. C is equals to F lambda. Let's see, let's just see. Okay, never mind. So C is equals to F lambda, for all visible light and also electromagnetic waves, shares the same property, C, because they all move at the speed of light. Alright? C is equals to F lambda. So this is a constant. The speed of electromagnetic wave in which include the visible light, in vacuum is constant, which is equals to C. Okay, if we look at red light, it has lambda is long. It's very long. It has this one, jarak gelombang dia, the wavelength